Alrighty, ladies, we are going to finish up the gold sheet with our practice word problems from yesterday. We're going to turn it over to the back and work on problem number 2 together. So number 2 says, an amusement park charges $20 for an all-day pass, $10 for a late-night pass. On Wednesday, the park collected $1,000 in pass sales altogether. This situation can be modeled by the equation 1,000 equals 20x plus 10y. And then it even tells us x is the number of all-day passes, and then y is the number of late-night passes. So if we want to graph the function, I went ahead and drew in our axes already. We know we want them to look like an L because x and y stand for real things. You don't have negative passes sold. That wouldn't make sense. So we've got our L-shaped axes, so go ahead and draw yours in. And then this would be easy to graph using our intercepts. So if we want to find our x-intercept, we are going to plug in 0 for y, which means we can just cover up y. So then our equation is 1,000 equals 20x. We're used to seeing this flipped around, 20x equals 1,000. If you want to flip it around, you can. Otherwise, we solve just like normal. We solve by dividing both sides by 20. Plugging that into our calculator, we can reduce by 10. We get 50. Our x-intercept is over at 50. And then let's figure out what our y-intercept will be. Well, to find our y-intercept, that means we're going to plug in 0 for x, and we get the equation 1,000 equals 10y. Just like before, we're going to solve for y by dividing. It cancels, and we find that our y-intercept is 100. So remember that your x-intercept is where your graph crosses the x-axis. So my x-axis over here needs to go out to 50. Maybe we'll count each one by 10. So maybe every other one will be 10. Okay. So 10, 20, 30, 40, and 50 takes us right here. There's our first intercept. Then to find our y-intercept, we are going to go up to 100. So maybe this time every tick mark will stand for 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And we plot our y-intercept right there. Then we want to connect our points with a straight line. We will not want arrows on either end because our graph stops at those intercepts. You can't sell negative passes, whether they're the late night ones or the all day ones. So all we want to do is connect those 2 points with a straight line, and our graph will look like this. Now in example B, or part B, I guess, when we want to identify our domain and range, remember our domain is all of our inputs, all of our x's. Well, when we remember that x is the number of all-day passes sold, the minimum number of passes, the minimum number of passes they can sell would be 0, right? So x, smallest it's going to be is 0. But the largest it's going to be, well, the biggest x we used was at that intercept. So that intercept was 50. So that's the biggest we can use. Remember, we can also start with our numbers, right? So we want to go from 0 to 50. We put our variable in between. And when it's a double restricted domain or range, it's always less than or equal to, less than or equal to. And that's for our domain. For our range, remember that's all of the y's that we used. Well, our smallest y is late night passes we sold. The fewest number of tickets we can sell is 0. The most number of tickets we can sell, the biggest y-coordinate we had, was our y-intercept, up at 100. So we go from 0 to 100, we put our variable in between, less than or equal to, less than or equal to. And then what does our x-intercept represent in this problem? Well, remember that it's an ordered pair. So if we go back up to our graph, that ordered pair was 50, 0, right? X stood for number of all-day passes. So this is just saying you could have sold, or they could have sold, the amusement park, might have sold 50 all-day passes and 0 late-night passes. So x-intercept, 50 all-day passes, but 0 late-night passes. And then they don't tell us how many of each we are really dealing with. So 50 all-day passes, 0 late-night passes could have been sold, right? Because we know altogether that they made $1,000. We don't know for sure how many of each they sold. But one possibility was 50 all day, 0 late night. So then the next question, what does your y-intercept represent? Well, that would be just the opposite. So that ordered pair is 0, 100. So that would mean 0, x stood for all day passes, y stood for number of late night passes. So maybe they sold 0 all day passes, 100 late night passes. You always have to remember for these problems that your x and y stand for things. And if they don't tell you in the equation what x and y stand for, take a look at what's being asked and see if you can deduce that way. Oop, not 0, sorry, 100. 100 late night passes could have been sold or could be sold in order to make the $1,000 they were talking about. Could have sold. Close. Alrighty. E, if the park sold 24 all-day passes, how many late-night passes did they sell? Well, they gave us a value to plug in. The all-day passes, go back up above, x is the number of all-day passes. So if they give you a number of all-day passes, that means they want you to plug in x equals 24. So our equation is 1,000 equals 20x plus 10y. And then we are going to plug in 24 for x and then solve for y. We want to know how many late night passes were sold. Well, y stands for late night passes, so this makes sense. So our equation is now 1,000 equals 20 times 24 plus 10y. 20 times 24, simplifying the right-hand side, will give us 480 plus 10y. And then our goal is to get y by itself, so that means we will subtract 480 from both sides. Oopsies. So 10y equals 520. Excuse me. And then lastly, to get y by itself, we undo the last thing attached to it, which is the 10. It's attached by multiplication, so to undo it, we use division. Y equals 52. So our question was, if they sold 24 all-day passes, that means they had to have sold 52 late-night passes in order for them to have made $1,000. And lastly, identify another possible combination of all-day passes and late-night passes. This is definitely something that you will see on your quiz. So in order to do this, we have two options. If you can take a look at your graph and spot any of these places where your line very clearly crosses any of these corner points, these are all actually on corner points, that worked out really well, and really quickly pick out those order pairs. So this guy right here would be 30, 40. This one right here would be 25, and then these ones were by 10, so 50, right? And remember that your X stands for all day passes, Y stands for late night passes. So that ordered pair means, oh, you could have sold, or they could have sold 25 all day passes and 50 late night passes. That would be a possibility. Now, if they didn't do that, or if your graph is not set up nicely where they are crossing nice curved lines, what you can do is you can just pick a number, either for your X or for your Y. Let's go ahead and pick X equals 10. So we do exactly what we just did in part E, except we just pick a random value. So if we pick x equals 10, we can rearrange and solve for y. So 100 equals 20 times 10 this time, plus 10y. 20 times 10, we get 200, plus 10y equals 1,000. My goal is to be solving for y, so that means I'll subtract the 200 first. And we have 800 equals 10y. Oopsies. So then we divide by 10. Y must be 80. So that combination, just by picking a random x in my domain, would tell us, well, maybe they sold 10 all-day passes. Remember, your X stands for all-day passes. And 80 late-night passes. And that would be another possibility or a possible combination of what they would have sold.